Okay, hello everyone. Today we'll be discussing the relevant classes for event organizer company management system. As you can see, here is my report on the screen that specifies the according classes, which are event, customer, vendor, attendee, bill, and task. So the event is basically the class that will be a blueprint for every event object, which has attributes as ID, which is primary key, title, location, date, so on and so forth, and customer, vendor, attendee, bill, and task. As you can see, we have interesting attributes, like unusual ones, such as is adult. So rather than having a birthday attribute, which may stress the system with the data type and the weight of it, I just have a is adult variable that is the Boolean type. It's yes or no. Since if the customer is over than 18, the legal actions will be different. If he or she is younger than 18, it's going to be different. Let's go to the source code of the program. Let's start with attendee class. As you can see, the class is serializable so that we can back it up and read it back from the data file. ID is the primary key. It helps us to identify each customer independently, distinctly. Full name, phone number, and email. In order to save some space, I set it up with the full name rather than first name and last name. Here are the getters and setter methods. And as you can see, we have a toString function placed within the class scope, which is basically when you like to read it or write it to a file. This format helps you to organize it more, make it in a way that more human readable way. And also whenever you like to print it out, like in a listing function, here is a blueprint for the expected output. Bill, as you can see, ID, date, and total fee. And since it's a money amount, it should be a double type, not an integer type. Setters, getters, and toString. Customer, nothing different here. Parameterized constructor, getters, setters. As you can see, his adult attribute is placed here, and it's Boolean. And it's also placed in attendee class. If the party or the event gonna be alcohol oriented, maybe not adult ones, non-adult ones will not be added to the event. Event class, yes, ID, title, location, date, concept, budget, approximate attendee, and adult only. If the Boolean adult only variable is true or yes, no attendee that is not adult will be led to the party or the event itself. Getters and setters. So as you can see, event class has composed attendee objects and task objects. What does it mean? So when you think the attendees and tasks and bill cannot exist without the context of an event. If there's an attendee, there should be a relevant event, and if there's a task, there should be an event that requires that task. If there's a bill, there should be an event that is associated with that bill. So I've used composition method, basically event class that is owning the array list, basically a container that contains multiple objects of attendee class and task class. This is implementation of the basic composition. So what we have different here, getters and setters, usual ones, add attendee and add tasks. What does it mean? As you can see, our parameterized constructor doesn't require any kind of what is it called? Yeah, basically it does require a container, but whenever you like to add new attendees, when new attendees occurs, you're able to use that function to add attendee to the list of attendees, which is C++ vector equivalent. You can add the new attendee to the list, and also you can add new task to the container as well. And you can remove them by expecting the ID of the attendee, and we're gonna iterate through the whole list. If the ID matches, we're gonna remove it and break the for loop. And also you can remove the tasks. So here is the reference returning functions. Like what does it mean? This function is returning a list of attendees, but unmodifiable. That means a constant reference will be returned from the get attendee list. But what does it do? Since we respect encapsulation rules, we set it to the private. We set our containers to private encapsulation level, so we cannot access them out of the event class. And since we would like to access it from outside, from the main or from the facet class, we should sort out a way to access it from outside. Yeah. So this function basically returns a reference to the containers we have, but basically it's unmodifiable. So the one who accesses it cannot manipulate it, but can read it and list it from the main or the facet class. And also here's a toString function. So basically, as you can see, the event is managing the attendees, tasks, and build classes, because that is the only correct way we can associate each attendee with each event, each task with each event. You can handle this up with the IDing system, like a database format, but that wouldn't be relevant for such programming course. Here is the task vendor, and here is the eManage class. So what is eManage sys class? It's basically called event managing system. This is the main controlling main facet class that owns everything we have. As you can see, the event manages the tasks and the attendees. Now, event managing system, the main facet class, owns the events, customers, and vendors. Since e-managing system owns the events, it also owns the attendees and the bill and the tasks. So there's a composite layer, as you can see on the class program, and we have customers and vendors. Why the customer and the vendor is not composed within the event, but it is in the e-manage system. Since the customer and the vendor can exist without an event, it's not compulsory to associate them with an event, and each vendor is split from any kind of event. They are not composed within the event, but in managing system it's composed because we need them. As you can see, the add event, add customer, add vendor, remove, list. It's basically printing out. This is the range based for loop, by the way, rather than having a variable that iterates through 0 to 10 or the size of the container, which is stated like this: for every event in event list, printed out. And that invokes the string function that the class contains within itself. List customer, list vendor, get event list. Such as in the event class, we have the get constant references from the getter from this function, so that we can access it from the main. We had functions that returns constant references from event class so that we can access it from eManage system, and we have functions that returns custom references of events and customers and vendors so that we can access it from the main. And here are the backup function and restore functions. Backup basically throws relevant exceptions if there is one, and is trying to write the object to the data folder and the events data file. If it fails, it throws an exception. And we restore it. It's basically we're reading the object within the events.data file, and we explicitly cast it to the list of event object type and copy it through the copy constructor of event list. We back up the customers list, vendor list, and that's it. Let's go back to the testing part. So there's no global term in Java, but let's say I have declared a kind of global object of the eManage system in the class so that we can access it from everywhere. If I were to declare and define it within the main, we couldn't be able to access it from the free functions we have. So I've basically declared and defined it kind of public, let's say. Init all test data basically creates the customer objects, event, vendor, all kind of relevant objects, and pushes them through the eManage system so that we initialize all the system with such arbitrary information. We initialize all the data. Let's start with listing. So sys is our object name. Sys list customers, let's say. Let's save. And run. Build success. As you can see, as the function initialized the information about the customers, we can list them with no issues. What if we would like to remove one? Let's say sys.remove. We were too fast. .remove customer. We should state an ID, give an argument of ID so that it can match it and remove it from the container. Let's say Aisha with the ID of 4. Save this, run this. As you can see, it's removed from the container, so whenever we list it, we don't see it on the list. Then we would like to back it up to our file, let's say. Sys backup customer list. Now, with the such state, as it initializes in the function, it's going to be backed up to the relevant file. Now, we're going to initialize it again, and we're going to remove customer with the 4 again, but then we're gonna restore customer list from the data file we have. Since we removed the customer 4, it shouldn't be outputted to the list at the end as we expect, but it will it be? Let's see. We're going to initialize all the data, we're going to remove it, and we're going to restore the customer list and list them. So what happened here? Initialize all the test data basically places the information, the data, on the memory, not persistent data file. So we initialize the data on memory, we removed it from the memory, but we restored from the 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 file. So whatever on the RAM is not important anymore because it's overridden by whatever in the file. Then we list it since uh, the ID of 4 exists in the data file, even though it's not existing in the memory, it's overridden, and as you can see, it's on the screen. And that's it. Thank you for listening.